Okay, so I start here from the last thing that I did not mention, but it should be obvious, but I should have mentioned it. Of course, a has to be a strictly greater than 0. It cannot be 0 because then the whole thing collapses here. Secondly, it has to be greater than 0 because it's coming out of the square root. Okay, so positive and never 0. So finally, let's start with 7.1. We got to 7.1 integration by parts. So this is the second technique of integration. What was the first one? Well, the first one was substitution. If you want, you can say, well, what about the simple one? Okay, I'm going to say 0, simple. What is simple? Like the integral from sine x dx. Doesn't need anything. So this is negative cosine x plus a constant c. Done. So simple substitution. And this is the third one if you want, or the second one. Okay, so integration by parts. I present this method slightly differently. It's up to you if you want to use this method or any other method that is legitimate, of course. So where does the integration by parts come from? It comes from differentiating a product. So the product rule states that this is f prime of x times g of x and plus f of x times g prime of x. Fine. Now what happens if we integrate the left-hand side? Of course, don't forget dx. And we integrate the right-hand side. Of course, don't forget dx. I already separated into two integrals. Don't forget dx. Let's see what happens now. When we integrate by the fundamental theorem of calculus part 1, when we integrate a derivative or we differentiate an integral, we get the function back. So we get here f of x times g of x. Here there is nothing I can do, so I'm just going to copy them again. So the integral from f prime of x gx, of course dx, plus the integral from f of x g prime of x dx. Now, integration by parts deals with this or this. It doesn't matter. They are the same. How come? Well, I can reverse the functions. Doesn't matter. So when we talk about integration by parts, we are solving this equation for this or for that. It doesn't matter which one. We can always reverse the order of the functions. Okay, so I think I'm on page, what page I am on? 8. Okay, so I'm going to solve this equation for this, moving this integral to the other side. So the integral from f prime of x gx dx, g of x dx, equals f of x g of x, product, minus this, the integral from f of x g prime of x dx. How does this work? I'm going to show a few examples. I hope you're going to find them very, very easy. And you're going to use this method. However, feel free to use any method you like. Okay, I would like to start with 25 on page 491. It's the integral from, I'm changing z into x, it's easier for me to write. Forgive me for that. So it's x to the third e, I think it's e squared, z to the third e to the z, of course, e to x dx. Good. So this integral has to be this. So then I can apply the method. But how can I make this into something with a derivative in it? Very simple, because e to dx is its own derivative. So I can rewrite this integral as You can multiply them using commutative rule if you want to keep it exactly in this order. So I'm going to write e to the x prime, x to the third dx, where f, not f prime, f is e to the x. I have f prime, g of x is x to the third. So knowing this, now I can apply the formula. So let's apply the formula. F times g, f, not f prime, f times g. Okay, e to the x, x times x to the third. Then minus the integral from. Now I copy f, which is e to the x. But I have to differentiate g. Fine. Times 3x squared dx. Okay. Moving on. Copy the first one. I can reverse it now. X to the third e to the x. I can take 3 outside the integral. It's a factor. And I have e to the x times x squared dx. Okay. So now, again, I'm looking at this, and I realize that e to the x is the same with e to the x prime. So I have x to the third e to the x minus 3. I'll replace again e to the x by e to the x prime because it's the same thing, x squared dx. Now I copy x cubed e to the x. I copy negative 3, and I open a bracket just to make sure I don't forget to distribute it. So I'm here now. So I have f of x gx e to the x times x squared. Then the formula says minus. Now I have the integral from f now is back to e to the x, of course, which it was. But I have to differentiate x squared. No problem. At this point, I will distribute negative 3. X to the third e to the x minus 3, x squared e to the x, but plus 3, the integral, times 2. Okay, let me write it again. 2x e to the x dx. Okay, so x to the third e to the x minus 3, x squared e to the x, of course, plus 6. The integral from, I present it in the same specific order so you don't get confused. Okay, final step then. All I have to do is apply integration by parts one more time. X to the third e to the x minus 3, x squared e to the x plus 6. Oh, fg minus the integral from e to the x, but x prime, which now is 1. Finally. Good. So I have to distribute 6. So this is x to the third e to the x minus 3, x squared e to the x plus 6x e to the x minus 6. And the integral of e to the x, we know it's e to the x plus a constant c. So we applied integration by parts, realizing that e to the x can be easily changed into e to the x to a prime because it's the same thing. That served the purpose because we really needed to have the f prime and the g. Once I have f prime g, then the answer is fg minus the integral from fg prime based on the product rule. Okay, let's look at other examples. I'm on page 9. So this was 25. Let's look at 33. Same page, 491. And 33 is the integral from 1 through 5 from natural log x over x squared dx. Again, by inspection, because we already looked at the preliminaries. By inspection, I know that this is the integral from 1 to 5. I have 1 over x squared, which I will change into negative 1 over x prime. Negative 1 over x prime, as we discussed in the previous video, is 1 over x squared times natural log x dx. I have my f prime and I have my g. So then the integral from f prime g, right, is fg, negative 1 over x natural log x from 1 through 5, negative the integral from 1 to 5 from, now I copy f, not f prime, just f, negative 1 over x, times g prime. Nice. Of course, dx. Great. So now here I can finish it up, plug in 5, negative 1/5 natural log 5, but minus when I plug in 0, this is 0. I'm sorry, when I plug in 1, this is 0. 0 times negative 1 would be 0. So this is only this. Now, negative with negative, positive, the integral from 1 to 5 from 1 over x squared dx. Nice, again. So this is negative 1/5 natural log 5. And this is negative 1 over x from 1 through 5 based on the preliminaries that we looked at today. So finally, negative 1/5 natural log 5. I plug in 5, negative 1/5, but plus, because I have a minus in 5, 1. So this is 4/5 minus 1/5 natural log 5. And this was obtained using integration by parts. Okay, so let's look at 13. On, I said 491 and I wrote 49. Sorry. So 490. The integral from cosine inverse x dx. Be careful, this is not 1 over cosine. I always prefer this notation because this is not confusing. This could be confusing, okay? But it's not confusing because it should be this in order to represent 1 over cosine x. This is the inverse function, which is arc cosine. Okay, so what do I do now? I only have one function. Not really. Look at this. I have two functions now because x prime is 1. So back to the formula. I have f prime g. This is f prime, and this is g. This is dx. So then I have fg, no problem. And then minus the integral from, I keep x, of course, because that's the f now. I differentiate this. I hope you all remember negative 1 over the square root of 1 minus x squared dx. Okay. So how do we proceed? That's my page 10. Okay. So I didn't have room there, so sorry about that. Good. So x arc cosine minus plus, because there is a minus already. So I have x dx over the square root of 1 minus x squared. Now substitution comes in handy. We did that in chapter 5. I'm going to say let u be the square root of 1 minus x squared, where du equals 1 over 2, the square root of 1 minus x squared multiplied by negative 2x, and of course times dx. The 2 with the 2 go away, so then du is only negative x dx over the square root of 1 minus x squared. How nice. I'm only missing, I have the x, I have the dx, I have the square root. Who cares? I only have a minor adjustment to make. Fine. I will multiply by negative 1 twice. Okay, so I'm going to use a triangle this time, jump over all this. So x arc cosine x minus the integral from du. Everything else, everything here is just du. Fine. So x arc cosine x minus u plus a constant c. But u has to be replaced. So this is x arc cosine x minus the square root of 1 minus x squared plus a constant c. And that is done as well. How are we on time? Good. Okay, so I'd like to look at two more problems and then I'll stop. So 23 on 490, the integral from e to 2 theta sine 3 theta d theta. With this problem, we have two options. We can work on e to 2 theta, as we did in the preliminaries, or we can work on sine, as we did in the preliminaries. It doesn't matter. I'm going to keep e to 2x, my change. So I'm going to change this into e to 2 theta over 2 prime sine 3 theta d theta. Is it true? Yes. When I differentiate this, I get that. But now I'm all ready for applying the integration by parts. I have the f prime. This is the f, and this is f prime. And I have g of x. So now I continue. F times g minus the integral from f g prime. So I'm going to move on to the next page. Okay, I'm on 11. Good. So fg, e to 2 theta over 2 sine 3 theta. Now minus the integral from e to 2 theta over 2 times this prime. When I differentiate this, I get cosine 3 theta times the inner function prime times d theta. So 3/2 will go in front. So e to 2 theta over 2 sine 3 theta minus 3/2 the integral from e to 2 theta cosine 3 theta d theta. Okay, I will play the same game one more time and you'll see what happens next. So I will replace this. So e to 2 theta over 2 sine 3 theta minus 3/2 the integral from e to 2 theta over 2, be very careful here, cosine 3 theta d theta. Leave this alone, of course. This is done. Minus 3/2. Please use brackets because you don't want to forget to distribute. So f times g minus the integral from e to 2 theta. Maybe I shouldn't write it here. Sorry about that. There is not enough room and I don't want to confuse you. So I'm going to do this. There are not two minuses here. Just this minus says look for something else that follows. Okay, minus the integral from e to 2 theta over 2 times this prime, which is negative sine 3 theta, don't forget parentheses, multiplied by the inner function prime and times d theta. Okay. Moving on, e to 2 theta over 2 sine 3 theta, 3 over 2 times 2 minus 3/4 e to 2 theta cosine 3 theta. Careful now. Negative 3/2 with negative and another negative. So maybe I should do it in 2 steps. So 3 over 2 with 3 over 2 multiply. So it's negative. So one negative, another negative with another negative. So negative 9/4 e to 2 times. There is no room. So the integral from e to 2 theta sine 3 theta d theta. Okay, so there is, maybe I should put it here so you don't get confused and don't separate them like that. So maybe that's better. So we just want to clear that. Good. Now, notice one thing. I'm going to stop here and say full stop. And I will go back to the original problem. This was the original problem. And what did I get? A term, another term, and the same integral again. So yes, with a number in front, of course, but it's the same integral. So we're going around in circles. I stopped because I got back the original integral. So I'm going to copy the beginning, this, and I'm going to copy 1, 2, 3 terms, and then I'll show you what happens. So the beginning of this whole thing was the integral from e to 2 theta sine 3 theta d theta. And here's what I got. I got e to 2 theta over 2 sine 3 theta. I got minus 3/4 e to 2 theta cosine 3 theta. And I got minus 9/4 the integral from e to 2 theta sine 3 theta d theta. Fine. Okay. I'm going to stop here, just start another video because I exceeded to 20 minutes.